Your front end is finished, shipped. You used an AI agent to build the entire interface in a single afternoon, and the result is actually impressive. The UX is clean, the features work, and your team is ready to push the whole thing live. Then you hit the wall. You realize you don't actually have a backend. Not a real one, anyway. You have a database sitting somewhere. You might have a few cloud services scattered across different subscriptions. You probably have some authentication you bolted on at the last minute, along with a few API endpoints that don't quite fit together. Now you're looking at weeks or months of plumbing just to get these systems talking to each other before you can even think about production. This is the middleware crisis. It isn't a new problem, but it's about to kill your ability to move fast. Custom APIs have become the primary bottleneck in modern application development today. The issue isn't the code or the design or even the deployment. The problem is the backend. It's the glue and the infrastructure that nobody wants to own, yet everyone is forced to live with. Most organizations are currently drowning in fragmented middleware that they can't maintain and don't fully understand. The real danger here isn't just a lack of speed, it's the crushing weight of governance and technical debt. This episode reframes the backend problem entirely and introduces the structural replacement you actually need. Subscribe to the M365 FM podcast for insights on Microsoft 365, Copilot, Azure, and how the modern workplace actually works. Why custom APIs became a liability. You built your first custom API because you had to. Your data didn't fit into a standard service, and you needed something specific, so you coded it yourself. It made perfect sense at the time. Then you built another one, and then another. Each new API solved a different problem and connected to different data. Each one had different consumers, requirements, and constraints. Before long, you were managing 15 custom APIs, and none of them talked to each other the way they were supposed to. The assumption that custom-coded middleware provides flexibility is broken. It looks flexible at the start because you can do whatever you want, but flexibility without structure eventually creates sprawl. That sprawl becomes unsustainable. Here's what actually happened in your organization. You built separate APIs for every single integration point because every request was urgent and every team needed a solution yesterday. Instead of designing one coherent backend, you created a series of point solutions. You ended up with separate databases, separate auth mechanisms, and separate monitoring strategies for everything. Now imagine multiplying that mess across dozens of teams over the last 5 years. Every custom API you own requires its own authentication, its own monitoring, and its own versioning strategy. You didn't choose this complexity, but the structure of your development process forced it on you. If your first API uses OAuth and your second uses API keys, you haven't gained flexibility. You have created inconsistency, and that inconsistency is a massive security liability. Think about the actual cost of this approach. Every time you add a custom API, you are adding a new surface to patch and a new system to monitor. Every time you deploy a single API, you have to check if it breaks the 5 others that depend on it. When compliance asks for an audit trail, you find yourself hunting through 15 different logging systems just to find one answer. Technical debt accumulates invisibly while everything seems to be working fine. For years, the APIs are fast and reliable, and nobody complains about the underlying structure. Then one day you need to change how authentication works across the entire platform, or you need to enforce a new data policy. You suddenly discover that 2 APIs are serving the same data in different formats, and they have drifted so far apart that reconciling them is now impossible. Now a single change takes months to complete. You are stuck coordinating across multiple teams and negotiating API contracts while trying to manage backward compatibility for systems that were never designed to evolve together. The real cost of your backend isn't the initial build. It is the maintenance burden that grows silently until you are spending half your engineering capacity just to keep the lights on. Custom APIs fragment your security model by scattering auth, encryption, and access control across different places. Zero trust becomes impossible when you can't even define where your perimeter is. Your data flows through 15 different systems with 15 different security policies, some of which you wrote and some you forgot about years ago. This is why custom APIs became a liability. They solved problems in isolation, but in the modern workplace, isolation is the most expensive mistake you can make. The architecture problem nobody talks about. The real issue isn't that you have too many custom APIs, because the actual problem sits much deeper than that. It is architectural. Traditional backends are built on layers where data lives in one place, business logic lives in another, and governance sits somewhere else entirely. Maybe your stack has 3 layers or maybe it has 5, but the fact that they are separate is the root cause of everything that is currently broken. Every time you separate a concern, you create a boundary, and at every one of those boundaries, you need translation logic to keep things moving. You have to move data from one layer to another while enforcing rules at each crossing point, and then you have to log what happened and secure the connection. That translation logic, the messy glue code between layers, is exactly where complexity starts to metastasize. Your database has no idea what your security policies are, and your API doesn't know anything about your data quality standards. Your authentication layer is completely unaware of which specific fields should be masked for which users, so you end up writing custom code just to bolt these pieces together. You add middleware, you add validation, and you add transformation, but none of these individual pieces were ever designed to work together from the start. Now consider what actually happens when you try to build for a modern enterprise. Power Platform apps need a different back-end shape than Copilot integrations, and those Copilot integrations need different tool contracts than your AI agents. Because a mobile app requires different API patterns than a data pipeline, you end up with multiple custom APIs, all talking to the same data in completely different ways, instead of having one coherent backend. This creates a consistency nightmare for everyone involved. Your data has one definition in the database, but then it gets transformed by your first custom API before being changed again by your second one. By the time that information reaches your third integration point, you are no longer sure which version is actually the source of truth. Your teams spend their time arguing about whose transformation is correct, and your audit logs show different values for the same field, depending on which API was used. The moment compliance requirements enter the picture, the entire architecture collapses. Your first 5 custom APIs were likely built without anyone thinking about data classification because they worked fine for simple internal tools. Then suddenly you need to enforce sensitivity labels, or you need to implement column-level masking for certain user roles to prove that nobody accessed PII without authorization. Now you are stuck retrofitting every single custom API you've ever built. You are adding access control logic to each one separately and implementing the same policy 5 different ways, which is a recipe for disaster. If you discover a bug in your masking logic, you have to go back and patch it in every custom API independently. This isn't scaling, it is just chaos with version control. The deepest problem here is the total absence of a single control plane. With traditional custom APIs, your governance is scattered across the landscape. Authentication might be enforced at the API gateway, while data access control lives in the database, and audit logging happens in 3 different systems. Compliance then requires your team to trace through all of them just to answer a simple question about who accessed specific data and when. There is no unified view and no single place where you can define the rules for how data flows through your organization. You lack a central spot to monitor whether those rules are being followed or a single lever to enforce them when things go wrong. Instead, you are left with 15 custom APIs that have 15 separate governance models and 15 separate security assumptions. You have 15 separate audit trails and 15 separate ways for the system to fail. This isn't a problem you can solve by simply building better custom APIs, because you cannot engineer your way out of a structural flaw. The architecture itself has become the constraint. You have separated the concerns so thoroughly that they are now impossible to govern as a single coherent system. That is the architecture problem nobody talks about, and it is exactly the problem Rayfin was designed to solve. The Agentic AI catalyst. Everything we have talked about so far, the sprawl, the governance nightmares, and the technical debt has been manageable up until now. It was painful, but organizations survived for years with fragmented custom APIs because humans were the ones orchestrating most of the work. In the old model, a human reads a ticket and decides what to do next. That person calls the right API in the right order and handles the edge cases whenever something goes wrong. Then you introduce an agent. An AI agent does not work that way. It doesn't read a ticket and then wait around for a human to decide on the next step. It plans a whole sequence of actions, calls multiple APIs in parallel, and adapts its behavior based on the results it gets back. It makes decisions autonomously and does all of this with minimal human intervention. This is where your custom APIs hit a wall they were never designed to cross. Custom APIs were built for human-paced interaction where a request comes in and a response goes out. There might be some basic retrying logic if a connection fails, but the fundamental assumption is synchronous. The system expects one human, one request, and one response, assuming that if something goes wrong, a person will eventually notice and fix it. Agents operate at a different cadence entirely. They orchestrate complex tool calls and maintain state across multiple steps, which means they need to know which operations are safe to repeat and which ones are not. They need to handle failures gracefully without losing their context, and they require clear guardrails regarding what they are allowed to do. None of your existing custom APIs were designed with this in mind. You don't have an API that manages agent state across session boundaries, or one that knows if an operation is safe to retry. There is no API enforcing guardrails, and certainly no API designed to be called by an autonomous system making its own decisions. So what happens next? Your organization starts building agent applications using the custom APIs you already have, and it usually works for about 2 weeks. Then the agent does something unexpected and makes a decision your APIs didn't account for. It calls an API in a sequence that was never tested, or it hits an edge case that causes cascading failures across your entire infrastructure. Now you are back to retrofitting custom APIs just to make them agent safe. You are adding transaction support, rollback logic, and audit trails for every single decision an agent makes. You are adding rate limiting so these agents don't overwhelm your systems, and you're adding validation at every step to catch an agent trying to do something it shouldn't. Agents require fast iteration to be effective. Your team ships an agent, it fails in production, and you need to understand what went wrong so you can fix it and redeploy within hours. With custom APIs, this process is incredibly painful because you are coordinating fixes across multiple systems while worrying about breaking existing consumers. The gap between a prototype and a production-ready app has widened instead of narrowing. Early on, this gap was maybe 2 weeks to build a quick prototype and clean it up for deployment. Now, for agentic applications, that gap has stretched into months because your custom API infrastructure wasn't designed for autonomous systems. It was designed for human-paced request-response workflows that just can't keep up. Organizations trying to deploy serious agentic applications hit this middleware wall immediately. They either spend months retrofitting their legacy custom APIs, or they simply accept that agentic automation isn't viable at scale for their business. This gap is forcing a reckoning. Organizations have to make a choice. Either completely redesign the backend layer to support autonomous decision-making, or abandon the promise of agentic automation entirely. There is no middle ground anymore. What Rayfin actually is, not what you think. Most people get this wrong immediately because their brains try to shove Rayfin into a category they already know. You might be wondering if it is a low-code tool where you drag components onto a screen, or maybe a managed database service like PostgreSQL where someone else handles the operations. You might think it is an API gateway or just another backend framework, but it is none of those things, and the moment you try to fit it into one of those boxes, you lose sight of what makes it actually different. Rayfin is a backend definition framework, which is the simplest way to describe what it does. It is an open source SDK and CLI that allows you to describe your entire backend in code rather than clicking through a UI or picking from a list of templates. You are essentially writing your application backend as code, much like you would write infrastructure as code to ensure everything is precise and repeatable. To understand what that means concretely, think about how you define your data models. You describe exactly what tables exist, which fields they contain, and how those tables relate to one another. You define your APIs by specifying which endpoints exist, what data they expect to receive, and exactly what they should return to the user. You handle authentication by defining whether you need OAuth or API keys, and you specify your storage needs for things like file uploads or blob storage directly in the code. You even define your access policies to determine who can read or write specific data and which fields should be masked for certain users. All of this lives in a single code repository as one source of truth, so you are never bouncing between a database config tool, an auth provider, and a governance dashboard. Everything is declarative and version controlled, which means every change you make is reviewable in a pull request before it ever goes live. When you are ready, you run the Rayfin CLI with one command, Rayfin up. This is where the magic happens because the CLI takes your backend definition and compiles it into actual services. It provisions a governed database, creates isolated functions, wires up the authentication, and configures the storage automatically. It does all the heavy lifting while enforcing the exact governance model you declared in your code. This approach is fundamentally different from the old way of picking a database and wiring it up yourself. In a traditional setup, you choose a database, then you choose an API framework, and then you spend hours trying to make them talk to each other. Then you have to bolt on authentication, access control, and monitoring as separate steps, and each of those steps introduces new ways for the system to fail. With Rayfin, you simply describe what you want, and the platform handles the plumbing for you. It knows how to connect every piece, because it was designed from the start to be a coherent whole rather than a messy collection of separate parts. The part that matters most is that Rayfin enforces a structural model that is opinionated rather than permissive. These opinions are baked into the system. It is code first, it is governed by default, and it is native to the Fabric ecosystem. Being code first means your backend definitions are versionable, testable, and easy to review. You cannot accidentally create a resource that lacks oversight because if a feature isn't in the code, it simply does not exist. Governance by default means you cannot opt out of security or compliance. You don't deploy a backend and then try to layer governance on top as an afterthought because the rules are part of the definition itself. When you mark a field as sensitive, the platform enforces that declaration immediately, and when an agent tries to access something it shouldn't, the system catches it before the operation even starts. Finally, being Fabric native means Rayfin does not exist in a vacuum. It isn't just another external service you have to figure out how to integrate. Your backend is a native part of Microsoft Fabric, so your data lands in OneLake and your functions run on Fabric Compute. This creates a unified control plane, which is the exact opposite of the fragmented architecture that has been causing so much chaos lately. Rayfin is not just a faster way to build a backend, it is a structural replacement for a broken model. It takes the painful lessons we have learned over the last 5 years and embeds them into a framework that stops you from making those same mistakes again. the Fabric integration, the real story. Rayfin does not live on an island. It isn't a standalone service that you just bolt onto your existing infrastructure, and that is the crucial detail that most people seem to miss. Rayfin deploys directly into Microsoft Fabric as a managed backend as a service, and this integration is where the entire model shifts in your favor. When you run that Rayfin up command, you aren't just scattering resources across random Azure subscriptions. You aren't spinning up a database in one place and functions in another while praying you can wire them together correctly. Instead, you are telling Fabric to create a governed database and isolated functions right inside your Fabric tenant as first-class artifacts. The word tenant is actually the most important part of that sentence. Your tenant is your organizational boundary and your security perimeter, which is exactly where your data governance policies live. When Rayfin deploys into that tenant, the backend you just created inherits every security feature Fabric provides as a fundamental part of its architecture. This creates a massive structural difference compared to the traditional way of doing things. Usually you build a custom API on something like Kubernetes or a Lambda function, and it talks to a database that lives in a separate cloud account. This creates two separate data estates, one for operations and one for analytics, which means you have the same data in two places with two different sets of security policies. You end up with separate audit trails and separate lineage tracking, which is a nightmare to manage. With Rayfin on Fabric, your application data lands directly in OneLake instead of an external silo. OneLake is the unified storage layer that already powers your analytics, your warehouses, and your data science workloads. When your Rayfin backend writes data, that information is immediately part of your analytics estate without any need for ETL pipelines or complex synchronization jobs. This means your operational data and your analytical data finally live in the same governed house. You have one classification system, one set of access policies, and one audit trail to watch over everything. If a sensitive field is masked for a user in an analytics report, that same masking is automatically enforced when that user tries to access the data through the Rayfin backend. Lineage now flows naturally through the system. Your Fabric models can reference tables created by Rayfin, so when someone asks where a specific metric came from, the trail leads all the way back to the operational backend. Data engineers can see exactly how everything connects without having to jump between 5 different tools and dashboards. Access control becomes unified because you only have to define who can do what one time. Those policies travel with the data itself. So if you want to restrict which agents can see sensitive fields, you do it once in the Fabric governance model. You no longer have to implement the same restriction over and over again across different custom APIs. Sensitivity labels work exactly the same way. If you classify a field as confidential in the Fabric labeling system, that label follows the data wherever it goes. Whether that data shows up in a Power BI report, a data scientist's notebook, or an API response, the access restrictions and audit requirements stay attached to it. The old wall between the operational backend and the analytics platform has finally collapsed. They are no longer two separate worlds that you have to bridge with duct tape and prayer. They are one integrated system. Your backend is now a part of your data platform, and your data platform has the power to act through your backend. This integration is the real structural shift. It isn't just about making things faster or more convenient, even though it definitely does that. It is about making governance unified instead of fragmented and letting data flow naturally through one system instead of being copied across separate universes. That is the real story of why this is different. Code-first governance, the philosophy. Every organization has a governance story, and it usually follows a predictable, painful pattern. You build the system, you ship the code, and then, much later, you ask the compliance team to take a look. If you're lucky, they give you a thumbs up, but more often than not, you're stuck retrofitting fixes to a finished product. In the worst-case scenario, you discover a massive violation in production and spend the next 3 weeks in emergency remediation mode. This is governance as an aftermath. It's a gate at the very end of the road. It's a checkbox. It's something that happens to your system rather than something that defines it. Rayfin inverts this model entirely. Governance isn't an afterthought here. It's embedded into the backend definition itself. From the moment you start writing your backend in code, you are making governance decisions, and the platform enforces those decisions before a single line of code gets deployed. Here's the practical difference. In a traditional setup, you define your data models first, and then you try to figure out who should actually see that data. You add authentication logic, you layer on authorization checks. You might even try to mask sensitive fields. But these are separate pieces of a puzzle that you're trying to force together. Your database schema doesn't understand your access policies, and your API has no idea what your classification rules are. You're bolting things on, and that's exactly where the gaps appear. With Rayfin, your access policies and business rules live in the code right next to your data models. They aren't hidden in a separate UI or managed in some third-party tool. They are declared right there in the backend definition. When you define a field for something like a salary, you aren't just setting a data type. You are declaring who can read it, who can change it, and whether it needs to be masked for specific roles. You're even deciding if accessing that field should trigger an audit event. The policy and the data travel together as one unit. This means your governance is versioned just like your code. You don't have to worry about your official policy drifting away from what's actually running in production. Your governance rules are reviewed in pull requests, they are tested in staging, and they can be rolled back if something breaks. When a stakeholder asks why a policy changed, you don't have to guess, because there is a commit message in your version control system explaining exactly why. More importantly, this governance is deployable. It isn't just a set of goals or a PDF on a shared drive. When you declare a rule and deploy the backend, that rule becomes the reality of the running system. There is no gap between what you intended and what actually happened. In fact, the platform won't even let you finish a deployment if your governance declarations are missing or if they contradict each other. This creates a very specific, very intentional constraint. Teams can't accidentally create ungoverned data stores. They might try to write a backend definition that skips the access policies, but the Rayfin CLI will stop them immediately. It will throw an error saying access policies not defined for table X, which forces the team to stop and make a choice. They have to explicitly declare who gets access, so they can't just skip the hard parts and hope nobody notices. The model forces a conversation. And because this happens upfront, you aren't dealing with these headaches months after the system is live. You're asking the big questions now. What should this backend be allowed to do? Who is allowed to touch this data? What information is actually sensitive? These aren't just technical questions, they are business questions. Rayfin brings them to the surface before the code is written and before you've built expensive dependencies that are hard to change. This shift from governance as an aftermath to governance as a blueprint is the real reason Rayfin matters. The technical features are great, but changing how an organization thinks about security and compliance is what's actually transformative. Once you start embedding governance into your definitions, building an ungoverned system becomes impossible. And when you can't skip the rules, you start making much better choices about what you build in the first place. The anti-corruption layer pattern. We all know that perfect is the enemy of done. And this is where we have to talk about the reality of your current tech stack. Most organizations aren't starting with a blank slate. You don't have the luxury of killing off all your custom APIs just to rebuild everything on a new platform. You have customers to support. You have systems that are currently generating revenue. You have dependencies that are so tangled you can't even track them all. Your teams are likely running on workflows that depend on APIs that mostly work. So what do you actually do? You can't just rip everything out and replace it, but you also can't stay stuck in the status quo forever. You need a way out that doesn't involve betting the entire company on a single migration. This is where we use the Strangler fig pattern. It's a concept borrowed from nature and used by teams that have successfully modernized massive, messy legacy systems. The idea is simple. You don't try to kill the old tree. Instead, you grow a new tree around it, gradually taking over its functions until the old one isn't needed anymore. In the world of software, that means building a facade. You might use an API gateway or a middleware layer that sits right in front of your old custom APIs. All your traffic hits this facade first. From there, the facade can decide whether to send a request to the old system or the new Rayfin backend. You start by sending everything to the old system, and then piece by piece you move functionality over. The secret sauce that makes this work is the anti-corruption layer. Think of this as a translation service. Your old APIs speak one language and your new Rayfin backend speaks another. The anti-corruption layer sits in the middle and translates between the two so they can understand each other. Let's look at how this works in practice. Imagine you have an old API that returns customer data in a very specific outdated format. Your new Rayfin backend is designed with modern principles and returns that data differently. When a user calls the facade expecting the old format, the anti-corruption layer steps in. It calls the new backend, transforms the data to match the old style, and sends it back without the user ever knowing the difference. It might feel like you're adding more complexity, and technically you are, but what you're actually buying is the power to choose. You can let your legacy systems live while you build something better right next to them. Rayfin can sit behind your gateway and work alongside your existing middleware. Your new backend doesn't have to replace the whole world on day one. It replaces one small thing, then another, and each time you do this, you're removing a bit of the old sprawl. This allows your teams to retire custom APIs one slice at a time. You aren't making a massive, risky decision to migrate from system A to system B. Instead, you're making small, manageable choices. You look at a specific workflow, decide it would be better on Rayfin, and move just that piece. One workflow, one translation, one conversation about whether the effort is worth the reward. The migration becomes doable because Rayfin keeps the new side of the house clean. You aren't just moving your data into another fragmented mess. You're moving it into a system with built-in governance and clear ownership. Once a piece is moved, it stays moved. It doesn't drift, it doesn't pile up technical debt, and you never have to go back and try to fix the governance later. This is how real modernization happens. It isn't about heroic all-night rewrites, it's about incremental replacement. The Strangler fig doesn't take down the old tree overnight, but it strangles it slowly, and by the time the old tree is gone, you've already built a healthy new ecosystem to take its place. Strategy matters, because for most of us, starting from zero is never an option. Technical debt retirement. Metrics that matter. The moment you decide to modernize, someone is going to ask the question that stops everyone in their tracks. They want to know which APIs you should retire first, and the honest answer is that you start with the ones that are most expensive to keep alive. But here's the problem. Expensive isn't always obvious because it isn't written down in a ledger or something you can feel during a meeting. You have to measure it, and that measurement is what transforms your migration from a religious debate into a data-driven decision. It starts with a simple principle. Not every custom API deserves to be retired, especially if it is still doing valuable work or running a stable process. Some of these systems have only 1 or 2 consumers who depend heavily on them, and if those teams aren't ready to move, you gain nothing by breaking something that actually works. The question isn't about which APIs you should kill off, it is about which ones are costing you the most in maintenance and risk. And you can find that answer if you're willing to look at the numbers. The framework you need is the technical debt ratio. It is a simple way to compare the cost of fixing a system against the cost of building it from scratch in the first place. If you have a TDR of 50%, it means rebuilding the system would cost half of the original investment, but a TDR of 200% means it now costs twice as much to maintain as it did to create. When you look at custom APIs, you calculate this by tracking incident rates, maintenance effort, and architectural complexity. An API that requires 2 hours of maintenance every month has a much lower TDR than one requiring 20 hours, just as an API with constant incidents is a much higher liability than one that works reliably. But TDR alone doesn't tell the whole story. You need operational signals like usage volume, because an API handling 100 requests a month is a very different candidate than one handling 100,000. The number of consumers matters too, since retiring an API used by 5 different teams is much more expensive than if only one team is connected to it. You also need to watch how often things change. An API that requires constant updates is a signal that you don't fully understand what it is supposed to do, and persistent incidents are just evidence that the system has become a liability. Then you should layer in your DORA metrics. You need to look at deployment frequency to see how often you can actually push changes. And you need to measure lead time to see how long it takes to go from a decision to production. You also have to track the change failure rate and the mean time to recovery, which tells you how long it takes to fix things when they inevitably break. These metrics reveal something that TDR misses. They show you exactly how much an API is slowing down your entire organization. An API with high lead time is keeping your teams waiting, while an API with a high change failure rate is making your entire platform unreliable. When you run these numbers across your entire portfolio, the patterns start to emerge. Some APIs are economic to keep, but the ones with high TDR, high incident rates, and high operational friction are your primary retirement candidates. The business case becomes obvious once you measure the cost of keeping these systems alive. You might discover you are spending 10 engineering years every single year just to maintain a system that only 3 teams use. You might find an API so fragile that a simple change takes 6 weeks to deploy, or realize that half of your incident pages are coming from the same 3 APIs over and over again. Measurement doesn't tell you what to do, but it does show you what is actually happening. And once you can see the reality of your system clearly, the decisions usually make themselves. The decoupled agent pattern. There is a new pattern emerging in systems designed for autonomous AI, and it is the complete opposite of how you probably build your custom APIs. Most custom APIs are monolithic. They know everything about one specific domain, they have opinions about how that domain should work, and they validate every request according to their own internal rules. They manage state across multiple requests and return responses in a shape that only makes sense for their specific context. This works perfectly for human-paced workflows. A person calls the API guesses what that person wants, and then it returns a response the human can understand. But agents operate differently. An agent doesn't call your API because it thinks your API is the perfect solution. It treats your API as just one tool among many. An agent might call your service, then hit a search engine, then query a database, and then call a calculation service all in one sequence. It is orchestrating a workflow across many independent services, which means your API is just a small component in a much larger machine. This shift means your API needs to change. It needs to be a tool rather than a monolithic system with its own opinions. You need a simple, predictable, schema-driven interface that an agent can use without needing to understand the deep history of your domain. Modern agentic systems are built on the principle of separating the agent orchestrator from stateless tools. The orchestrator acts as the brain that makes decisions and plans sequences, while the tools are intentionally dumb. They are called with specific inputs, they return specific outputs, and they don't know anything about what happened before or what will happen next. This separation is fundamental to the whole system. If your API is tightly coupled to business logic, or if it tries to maintain state about what the agent is doing, it loses its flexibility. It stops being a general tool and becomes a specialized service that only one specific kind of agent can use. Custom APIs actually make this problem worse because they were built for human-paced patterns. They try to maintain session state and return responses shaped for people, which forces an agent to track complex context and parse messy data. It is a fragile and inefficient way to work. Rayfin handles this differently by generating APIs that are schema-driven from the ground up. When you define a data model, the system automatically creates an API that reflects that exact schema. The contract is explicit, so the agent knows exactly what inputs to send and what outputs to expect without any guessing or implicit assumptions. More importantly, these APIs are stateless by design. When an agent calls one, it passes every piece of information the API needs as part of the input. The API processes that single request independently and returns a result, leaving the agent responsible for remembering the context and planning the next move. This stateless design creates a massive advantage. Agents can call these APIs without worrying about side effects or complex session logic because each call is entirely independent. The API either succeeds or it fails, but either way, the result is deterministic and predictable. This architecture is also what allows the system to scale. Because the tools are independent, you can run 10 instances of a generated API and the agent will distribute calls across them without any need for coordination or session affinity. Even your security model gets better with this approach. With old monolithic APIs, you usually give broad permissions that let an agent do anything the API allows. With decoupled tools, you give narrow permissions for specific operations, so the agent can't accidentally use a tool for something it wasn't designed to do. This architectural shift is exactly why this model works for AI-driven applications, where traditional custom APIs usually fail. Data minimization and security boundaries. Now we need to talk about what actually happens to your data in these systems, because the security model breaks down in a specific way that people don't usually see coming until it's too late. Custom APIs have a security problem that's almost structural. They expose too much data because access control was never baked into the design. You build an API, you're focused on making it work, making it return the right responses, getting the logic right. Access control feels like something to add later, something the security team will handle. So what happens? You build an endpoint that returns customer records. The endpoint works. It returns all the fields, all the details. Then someone asks, we need to restrict this endpoint so that finance can see salary data, but customer service can't. Now you need to add conditional logic. You add permission checks. You mask certain fields for certain roles, but you're doing this on top of an API that was never designed with this constraint in mind. The masking logic lives in your application code, not in your data layer. It's easy to accidentally return unmasked data if someone changes the code and forgets to update the conditional logic. With Rayfin, this is inverted. Row-level and column-level security is enforced at the schema level, not at the application level. When you define your data model, you don't just define fields. You define who can see them, who can modify them, whether they get masked for certain roles or redacted entirely. This enforcement happens in the platform, not in your code. You can't accidentally bypass it. An agent calling a Rayfin API can't see fields you've declared invisible to it. The platform enforces this at query time, before data is returned, before it touches application code. This is security by construction, not security you hope you've implemented correctly. The distinction matters especially for agentic systems. With custom APIs, you worry constantly about what an agent might be allowed to access. You add permission checks, you add validation, you review the agent's code to make sure it doesn't try to access sensitive data. But agents are code too. Code evolves. An agent might start with modest permissions and gradually accumulate the ability to do more. A human might not notice the scope creep until the agent has already accessed more data than it should. With Rayfin, you don't have that problem. An agent doesn't have permissions. The API it calls has permissions. The agent is just a consumer, like any other. If the API is designed to mask salary data for certain callers, that masking happens regardless of whether the caller is a human user or an AI agent. The boundary is enforced in the platform, not dependent on the intelligence or behavior of the caller. Sensitive data, PII, PHI, financial records can be masked or redacted automatically. You declare a field as sensitive, the platform knows what to do. It applies the appropriate protection based on who's accessing it. You don't have to implement this logic separately in every API that touches that data. The result is that your backend becomes secure by construction, not through vigilance, not through careful code review and permission management, but because the architecture itself makes insecurity hard to achieve. Because security is embedded in the data definitions enforced by the platform, not delegated to application code. This matters more than it sounds. The HorizonDB connection. AI-ready persistence. We've been talking about Rayfin as the orchestration layer, the framework that defines your backend, the control plane, the source of truth for how your application behaves. But orchestration without persistence is just thought experiments. You need somewhere to put the data, somewhere to keep the state that your backend depends on. This is where HorizonDB enters the picture. HorizonDB is Microsoft's AI native database. It's PostgreSQL compatible, which means if you know PostgreSQL, it feels familiar, but it's built from the ground up for modern workloads, the ones that Rayfin targets, the ones that need vectors alongside relational data, the ones that need AI capabilities baked into the database itself, not bolted on afterward. Here's the key distinction. Rayfin defines the backend orchestration layer. It's the declarative framework, the governance, the API surface, the business logic. HorizonDB is the AI native database layer. It's where data lives, where intelligence gets stored, where embeddings coexist with transactional data in the same system. HorizonDB provides something custom APIs rarely have: vector search, embeddings, and AI functions directly in SQL. Not through a separate vector database that you have to synchronize with your operational database. Not through API calls to external services. Direct in the database, in SQL. This matters concretely. When you're building a RAG system, retrieval augmented generation, you need to store documents and their embeddings. You need to search by semantic similarity. You need to re-rank results. You need all of this to happen quickly in a single query on data that's also your operational source of truth. With custom APIs and separate services, you'd replicate your documents to a vector store. You'd embed them separately. You'd query the vector store, then query your operational database to get additional context. You'd stitch the results together in application code. Each connection, each synchronization point, each opportunity for data to drift out of sync. With HorizonDB, your documents live in the database with their embeddings. A single query returns both the semantic matches and all related metadata. You don't replicate, you don't synchronize, you don't compose results from multiple sources. The database handles it. The AI functions are equally direct. You can call embedding models, classification models, re-ranking models directly from SQL within a stored procedure as part of a query. The database executes these functions and returns results integrated with your data. It's not fast in the sense of we managed to make network calls quick. It's fast because the computation happens where the data lives. Rayfin can target HorizonDB as the operational store for RAG and agentic workloads specifically. When you define your backend in Rayfin, you specify where data lives. You can say, use HorizonDB. The CLI understands this. It configures the connectivity. It sets up the credentials. It ensures your Rayfin-defined APIs connect to HorizonDB automatically. This combination, Rayfin orchestration plus HorizonDB persistence, is the modern stack for AI applications. Not because each one is individually impressive, but because together they solve the integration problem that plagues every custom API architecture. Vector indexes, hybrid search, and in-database AI functions reduce integration complexity dramatically. You're not gluing together 5 different services. You're not writing middleware to translate between formats. You're defining your backend in Rayfin, specifying HorizonDB as your data layer, and letting the platform handle the plumbing. The two services work together with clear division of labor. Rayfin handles business logic, orchestration, governance. HorizonDB handles data intelligence, AI capabilities, persistence. Each does what it's designed for. Neither tries to be everything. And together they eliminate the fragmentation that made custom APIs so expensive to maintain. Understanding how Rayfin integrates with HorizonDB reveals why the old custom API model was never going to work for artificial intelligence, observability, and agentic governance. There is a fundamental difference between knowing what happened and understanding why it happened. Custom APIs excel at the first part because they generate logs, timestamps, and error codes. If something goes wrong, you can dig through those logs and reconstruct the event, but reconstructing an event is not the same as understanding the decision-making process that led to it. With Rayfin, this distinction matters because your system is no longer just responding to requests. It is making decisions. When an agent calls your backend, that backend executes a sequence of operations where every step has context. You have input states, output states, policy decisions, and side effects. You need visibility into all of that rather than just knowing if the operation succeeded or failed. Rayfin generates structured traces instead of standard text logs. The difference is architectural. A log is just a record of a timestamp and a message, but a trace is a complete record of a decision and its consequences. You can see what input triggered the decision, which policy rules were evaluated, and exactly why certain rules were matched or rejected. Every backend operation is recorded with this level of granularity. When an agent calls an API, the platform traces the input, the permission evaluation, the data fetched, and the transformations applied. This information isn't buried in text logs you have to parse manually. It exists as structured data that is queryable, analyzable, and standardized across your entire environment. This level of observability is essential when agents are making autonomous decisions. In a human-driven system, you can ask a person why they did something, and they can justify their actions. Agents cannot explain themselves. You need the system to explain them by reconstructing the decision through the trace. You have to see the context the agent was working with and the constraints it hit to understand the choices it made. You can audit what an agent did, why it did it, and what data it accessed. This becomes critical for compliance. If a regulator asks you to prove an agent never accessed customer data without authorization, you cannot answer that by inspecting the agent's code. You answer it by running a query against the traces to show exactly which APIs were called and which access control policies were enforced. The audit trail is complete, verifiable, and tamper-evident because the platform generates it automatically. Behavioral baselining is the next layer of this strategy. Over time, you establish normal patterns for how your agents behave. A particular agent might typically call 3 specific APIs in sequence or access customer data 50 times per day. These numbers become your baseline, and they allow the system to recognize when something is wrong. When an agent deviates from the norm, you notice it immediately. If an agent suddenly starts calling 10 APIs instead of 3 or accesses data it doesn't normally touch, The system flags the behavior. It doesn't necessarily shut the agent down, but it alerts operations or triggers an escalation to a human. You could even apply guardrails to throttle the agent or require approval before it continues. The platform becomes auditable by default. It isn't auditable because of manual effort or because your team added logging to every line of code. It is auditable because the architecture itself produces audit-ready data. Every operation traces, every policy decision is recorded, and every data access is documented. The system isn't trying to be auditable, it's simply impossible for it to be opaque. This matters for two reasons. First, it acts as a control mechanism that lets you prevent problems before they cascade. Second, it provides the evidence you need when something goes wrong. You have complete records to show regulators, customers, and your own compliance team exactly what happened and why. Observability is not an optional feature for agentic systems. It is a requirement. While custom APIs require you to implement observability painstakingly, Rayfin treats it as a foundational part of the build. The governance board decision, organizational implications. This is where the conversation stops being about technology and starts being about organizational structure. Adopting Rayfin is not just a technical choice, it is an organizational one. The moment you acknowledge that shift, the way you manage your teams changes. When you deploy custom APIs, each team usually decides things independently. Engineering might decide their API lives on an app service, while the database team picks Cosmos DB and security bolts on authentication. Every team owns their own piece in a decentralized model. That is exactly how you end up with hundreds of ungoverned backends scattered across your infrastructure. Rayfin inverts this model. Adopting this platform means you are standardizing how backends get built across the entire organization. Not every workload will fit this model, but the ones that do will follow one pattern and one governance framework. That decision cannot be made by individual teams because it requires organizational consensus. This is where the governance board enters the picture. This is not a compliance committee that reviews things after they are already built. Instead, it is a decision-making body that defines standards before a single line of code is written. The board asks which workloads should use Rayfin, which are exceptions, and what guardrails need to be applied. The board makes these decisions because they have massive organizational consequences. If you decide all new backends must use Rayfin, you are betting that this model aligns with your long-term needs. If you decide only AI-driven backends use it, you are accepting the cost of maintaining multiple models. If you stay entirely custom, you are accepting the ongoing price of fragmentation. None of these answers is objectively right or wrong. The right choice depends on your risk tolerance, your technical maturity, and your timeline. However, these choices must be made deliberately and together. You cannot leave these decisions to each individual team to figure out on their own. Initially, this creates friction. Teams that want to build custom solutions often resist standardization because they feel their use case is special. They argue they need more flexibility or that they cannot work within the constraints of the platform. Some of these arguments are legitimate, but many are not, and the governance board's job is to distinguish between them. Over time, that friction decreases as clear roles begin to emerge. The platform team owns the Rayfin infrastructure, the SDK, and the deployment pipeline. Domain teams own their backend definitions and their code. They still make decisions about data models and access policies, but they work within a standard model. They no longer have to reinvent the infrastructure for every new project. This division of labor scales in a way that custom APIs never can. With custom APIs, every team has to understand the databases, authentication, networking, and security. That is an expensive way to work, and it is usually why security gaps appear. With Rayfin, the platform team handles the heavy lifting so domain teams can focus on business logic. The model scales because governance is standardized rather than repeated. You don't have to explain data classification rules 5 times to 5 different teams. You define them once. You don't implement access controls separately for every single API. You define those policies once in Rayfin, and the platform enforces them consistently across the board. The governance board decision creates real accountability. Someone has to decide which backends use the platform, and someone has to own the criteria for exceptions. When things go wrong, the board is there to answer for it. This means the decision gets made carefully because the organization is collectively betting on the model to work. The technical change is the easy part. The organizational change is the hard part. But if you want to move toward an agentic future, both are absolutely necessary. Cost and capacity management. Now, we are going to talk about something that usually matters more to CFOs than architects, but you need to understand it because it determines whether your strategy actually gets funded or dies during a budget review. It comes down to money. Specifically, where's that money actually going? When you build custom APIs, your costs are hidden and scattered across the entire organization. One team might have a database in subscription A, while another team runs functions in subscription B, and someone else has a storage account in subscription C that was set up years ago, and nobody even remembers who owns it. You end up with API gateways in one place and load balancers in another, and because monitoring tools are often purchased separately for different use cases, you can never see the full picture. The costs are distributed across so many different line items that adding them up becomes impossible. If you are a team trying to hide how much you spend, this is a great feature, but it is a total disaster if you are trying to make smart decisions about where to invest. Rayfin changes this by consolidating your backend infrastructure into Fabric capacities. This shift makes your costs visible immediately, allowing you to point to a single number and show exactly what these workloads cost every month. There is no mystery and no hidden line items buried deep inside cloud subscriptions. You get one capacity, one bill, and one number that you can actually reason about. This level of transparency forces conversations that simply never happened before. You can finally ask if a specific backend is worth its cost, or how much you are paying to keep a service alive that only 3 people are using. These are business questions rather than technical ones, but you can only ask them if you have the data. You can also start applying chargeback models to hold teams accountable for what they use. This does not have to be adversarial, but it is functional, meaning if the finance department wants a backend, they get one, and the cost comes directly out of their budget. When teams see the actual cost of their infrastructure, they start to think differently about what they really need. They become much less likely to request backends they won't use, and they are more likely to shut down the ones they don't need anymore. What you get out of this is rationalization. Without cost visibility, you naturally accumulate zombie backends, which are systems that nobody is actively using but nobody has decommissioned because the process is too painful. These systems sit there consuming capacity and accumulating technical debt while occasionally breaking and requiring your team to go into firefighting mode. Because Rayfin makes the cost obvious, you can finally ask why you are paying for these systems and then shut them down when the answer is that you shouldn't be. The reduction in operational overhead is just as important for your bottom line. Custom APIs require expensive people like database administrators to tune performance and engineers to patch security vulnerabilities. Fabric uses a managed model that eliminates most of this work because Microsoft maintains the platform while you only maintain your backend definitions. The result is a much lower total cost of ownership, even if your per-request costs look a bit higher at first glance. You are paying for the convenience of not having to manage infrastructure or hire a massive team to keep the lights on. The math works when you account for the incidents you don't have to fight, and the fact that zombie backends are no longer draining your budget. The self-service trap. What can go wrong? There is a specific risk that nobody likes to talk about at the start of a modernization program. Rayfin is powerful, and sometimes it is actually too powerful. If you give developers the ability to define backends this quickly without the right guardrails, you might not solve your original problem, and you might actually end up accelerating it. Think about what happens the moment you roll this out to your engineering organization. You tell everyone they can now deploy backends independently without waiting for infrastructure teams or dealing with months-long deployment cycles. You tell them to just write a definition in code and run the CLI, and their backend will be live in minutes. This feels like total liberation to an engineer, and for about 3 months, everything is great. But then you wake up and realize you have 30 different Rayfin backends running, and every single one of them has different standards. One team might decide to store passwords in plain text because they were moving too fast, while another team uses an unapproved data source that hasn't been vetted. A third team might set their data retention to never delete because they are afraid of losing something important. You haven't actually fixed the sprawl, you just traded custom API sprawl for Rayfin sprawl. This happens because Rayfin is a self-service tool that allows teams to make big decisions without any oversight. The platform is designed to enforce your governance, but it only does that if you actually define what the rules are. If you leave it blank, the platform won't invent those rules for you, and it will happily deploy whatever your teams ask it to. The solution here isn't to take the tool away or restrict access, but to make the right way the easiest way to work. You do this by creating templated Rayfin projects that aren't just optional suggestions or examples. These are the actual starting points that every team must use. A good template defines how to structure data, how to handle authentication, and exactly where the data is allowed to live. It sets the rules for retention and compliance checks so the teams don't have to guess what the standard is. Beyond those templates, you need a governance library that acts as a catalog of approved components. You can use this library to specify which databases are allowed and which ones are forbidden. You can define exactly how the organization handles OAuth or service-to-service authentication so that nobody is making it up as they go. This library does more than just document the rules, it actually enforces them. When a team writes a backend definition, they are constrained by the choices available in that library. They don't have unlimited freedom, but they do have structured choices that keep them safe. The platform will literally prevent them from connecting to an unapproved data source or deploying a service with an undefined retention policy. This enforcement happens at the moment of deployment rather than months later during an audit. If a backend definition violates your governance rules, the CLI validation will fail immediately. The team finds out right then and there, and they have to fix the issue before they are allowed to go live. This means there is no gray area and no "we will fix it later" excuses that lead to security debt. There is a real trade-off here because you are going to lose some flexibility. Teams cannot do exactly what they want whenever they want, and they have to work within specific constraints. However, those constraints are transparent and documented for reasons that actually make sense for the business. Most teams will accept these restrictions when they see the alternative, which is a governance nightmare where everyone is doing their own thing. Rayfin only solves your custom API problems if you take the time to govern it correctly. If you don't, you haven't actually solved the problem. You have just shifted it to a new tool. Migration strategy. The practical path. The question that kills most modernization programs is deceptively simple. When do we start? The trap is equally simple. You think the answer is next quarter, or perhaps you tell yourself it has to wait until the current project wraps up. But in reality, the only real answer is now. You start with a pilot, you set a defined scope, you secure clear sponsorship. If you wait for perfect conditions, you will be waiting forever. Start by choosing a pilot domain. Do not pick your most critical system or something the entire organization depends on to function. Instead, find one business area with a stakeholder who is ready to back you. You need something valuable enough that people actually care if it succeeds, but it must be constrained enough that a failure isn't a catastrophe. Finance, marketing, or HR operations are usually great candidates. Pick a spot where you can show a win in 6 months, because that is how you build the momentum you need to keep going. Once you have that pilot domain, you need to map out your existing custom APIs. Don't try to do this at scale across your entire portfolio yet. Just focus on the ones serving that specific domain. Document what they do, identify who is calling them, track exactly what data flows through them. You need to know which ones are ready to be retired and which ones are still working. This is the inventory step. It is boring, it is tedious, but it is absolutely necessary. You cannot strategically migrate a landscape that you do not understand. The actual migration happens behind a facade. You don't just cut over and hope for the best. You don't declare all your old APIs retired on a Friday and pray nothing breaks over the weekend. Instead, you run both systems in parallel. Your API gateway acts as the facade that routes the traffic. In the beginning, everything goes to the old system, and then you gradually shift that traffic over to the new Rayfin backend. The anti-corruption layer lives right behind that facade. Its job is to translate between the old API contracts and your new Rayfin services. Your consumers won't even know anything has changed. They call the facade using the same old contract they've always used. The layer translates the request, calls the Rayfin backend, and then translates the response back before sending it to the consumer. It is completely transparent. The consumer sees zero disruption to their workflow. When it comes to moving consumers over, you do it gradually. Start with read-only operations. These are much lower risk because if something breaks, you haven't actually lost any data. You might have just returned some stale information, and consumers are generally more forgiving of that. This phase lets you learn the failure modes so you can understand what breaks and why. Once you're comfortable, you move to write operations. Then you move to the critical workflows. With every step, you are validating that the new backend works, and with every step, you are building organizational confidence. As each custom API loses its consumers, it becomes a candidate for retirement. This isn't some dramatic flag-planting moment, it is purely administrative. When you notice an API has 0 active consumers, you simply file a retirement request. You give the relevant teams 90 days of notice and then you shut it down. That is one less system you have to maintain. That is one less source of potential incidents. That is one less piece of technical debt accumulating in your environment. But what happens to the teams that used to maintain those APIs? This is a critical organizational question. You cannot simply lay people off because you retired their system. You redirect them. Some of them will migrate to the Rayfin platform team to help maintain templates and enforce governance. Others will move into domain teams where they can finally focus on business logic instead of fighting with infrastructure. Some might transition to entirely different products. The point is that they stay. They don't become obstacles to your modernization because they understand they are moving towards something better. The pilot domain serves as your proof of concept. You migrate one system and show the world that it actually works. You show that costs went down. You show that incidents decreased. You show that the team is more productive than ever. That success is your leverage. When other domains see those results, they will start asking to participate. The program grows through demonstrated value rather than a top-down mandate. Every new domain that joins follows this exact same pattern. Pilot first, map the APIs, run in parallel, gradual migration, retirement, and reallocation. This isn't a one-time event that you finish and forget. It is a continuous process. You are always working on a domain, always retiring old APIs, and always reallocating your teams. This becomes your new normal operating rhythm. Migration isn't a revolution, it is an evolution. You don't blow up the old system and try to rebuild it from scratch. Instead, you slowly strangle the old way of doing things. You prove the new system works and then you retire the old one piece by piece. By the time you are finished, you have successfully replaced a massive liability with a solid structure. The Fabric Governance Foundation, what you inherit. There is a moment in every modernization project where someone realizes they have been solving the wrong problem. You have been thinking about governance as something you have to build, something you have to design, something you have to implement on top of your infrastructure. You build your own access controls, you build your own audit logs, you build your own compliance frameworks, then you bolt them onto your systems and you hope they actually work. But when you adopt Rayfin, governance doesn't work that way. You don't build it, you inherit it. This is the structural advantage that nobody really talks about when they are pitching Rayfin. It isn't just about speed or the developer experience. It is about the fact that Microsoft Fabric has already solved the governance problem for you. When you deploy Rayfin into Fabric, you get all of that work for free. Rayfin inherits the entire Fabric governance model, not just the pieces you like or the interesting parts, but all of it. Role-based access control, sensitivity labels, lineage, compliance frameworks, audit trails, data classification. All of these features work with Rayfin because Rayfin is deployed directly into Fabric. It isn't a separate system that you have to struggle to integrate. It is part of the governed system from the very first moment it exists. You don't need to build a separate governance layer for your backends because the platform provides it. This sounds obvious when you say it out loud, but in reality, it is a massive shift. Most teams treat governance as an add-on or a phase 2 project. They think it is something you implement once you've proven the technology works. With Rayfin, governance is there on day one. It isn't optional, and it isn't something you have to retrofit later. It is structural. Data classification happens automatically through Purview integration. You don't have to manually tag your datasets anymore. Instead, you define your classification rules and let Purview scan your data. It applies the labels for you. Financial data gets flagged as sensitive, and customer records are automatically marked as PII. The system understands exactly what it is looking at, and it acts accordingly. When a Rayfin backend stores data in OneLake, Purview already knows it is there. It classifies the data and enforces your policies without you lifting a finger. The audit logs capture everything. This isn't a situation where you hope you logged the important stuff. Every single operation is recorded, traceable, and immutable. You can see who accessed what data, when they did it, and what their purpose was. You can see exactly what policy decisions the system made. All of this is logged by the platform itself, not by your custom code. The platform generates the audit trail, and you simply query it when you need an answer. Compliance reviews become straightforward because the evidence is already there. When an auditor asks you to prove that you enforce data classification, you don't have to scramble. You just run a query against those audit logs. You can demonstrate that every single access to classified data was preceded by a policy check. You can show that the classification was enforced and that unauthorized access was denied. The evidence is right there in the logs. It is complete. It is verifiable. It doesn't depend on your team's memory or your code being perfect. Access control is enforced consistently across both your operational and analytical workloads. You don't have one security model for your transactional systems and a completely different one for your analytics. Both of them live in Fabric. Both of them use the same RBAC model and the same sensitivity labels. Consistency isn't a goal you have to work toward. It is just something you get because everything is sitting on the same platform. The platform becomes auditable by default. This doesn't happen because someone decided auditing was important or because your compliance team is being extra vigilant. It happens because the architecture itself is transparent. Operations are logged, policies are traced, data access is recorded. The system cannot hide what it is doing because the infrastructure forces that visibility. This inheritance model is what really separates Rayfin from those old custom API architectures. You aren't trying to build governance on top of an ungoverned mess. You are building on top of an infrastructure where governance is the foundation. It is enforced by the platform, which means it doesn't depend on your team's discipline to stay intact. That is the real value proposition of running Rayfin on Fabric. Agentic app deployment patterns, the future state. Fast forward 5 years into the future. Your organization is no longer just a collection of people using tools, but a network of autonomous systems where AI agents orchestrate every major workflow. These agents make real-time decisions within your guardrails, acting on live data without waiting for a human to click approve unless a specific policy demands it. This isn't a science fiction pitch. This is the exact direction where enterprise architecture is heading right now. The real question for your leadership isn't whether your company will eventually run these agents, but whether your underlying infrastructure will actually be ready to support them when you do. Agentic applications require a backend that is fundamentally different from the custom APIs we've been building for decades. They don't need passive systems that sit around waiting for a request, but instead require environments that support autonomous decision-making and complex tool orchestration. You need a system that allows an agent to plan a sequence of steps, recover when a process fails, and respect the boundaries of its authority. Rayfin provides the structural foundation this new era demands. We didn't just bolt on agent support as an afterthought to an old product. Rayfin was designed from the ground up to serve as the nervous system for autonomous enterprise systems. Consider the multi-agent coordinator pattern that is quickly becoming the standard for enterprise deployments. In this model, one coordinator agent receives a high-level goal and immediately decomposes that goal into smaller subtasks. It then routes those tasks to specialist agents who execute their specific pieces before the coordinator collects and validates the results against your business rules. The entire system operates autonomously within the specific boundaries you have defined. This works because Rayfin handles the heavy lifting of the orchestration layer. The coordinator agent doesn't have to worry about managing infrastructure, provisioning new databases, or setting up complex authentication flows. It simply calls APIs. Because those APIs are Rayfin generated, they are stable, predictable, and capable of enforcing their own constraints. The coordinator doesn't need to manage state across a dozen different services because each service manages its own state, allowing the coordinator to focus entirely on the flow of the work. Agents can call these services with total confidence because access control and data validation are enforced by the platform itself, not by fragile application code. An agent never has broad permissions or read-only access to a database. It calls a specific API, and that API dictates exactly what is allowed. If an agent calls a customer API to get a record, it won't receive sensitive salary information because Rayfin simply doesn't expose that field to that specific endpoint. The agent never even had the option to see it. Access control isn't a logic puzzle the agent has to solve because the platform enforces the rules before the agent can even ask. Validation happens long before any data reaches the agent's logic. A Rayfin API only accepts specific inputs with strict types, so if an agent sends malformed data, the API rejects the request immediately. If an agent tries to modify a field it shouldn't touch, the API blocks the action and returns a clear error. The agent can log that error and try a different approach, but it can never accidentally cause systemic harm through an invalid operation. The backend essentially becomes a safe sandbox where agents act autonomously within your defined boundaries. You aren't relying on the agent to be smart enough to follow the rules. Instead, the infrastructure makes it physically impossible for the agent to exceed its authority. This is security by design rather than security through trust. Think about a concrete scenario like an agent managing customer support tickets. It reads incoming messages, analyzes the intent, and proposes a response. Under the right conditions, it executes that response and closes the ticket or opens an escalation, all without human intervention. But there are hard boundaries in place. It cannot refund more than a specific dollar amount without a manager's approval, and it cannot access payment information or delete historical records. With custom APIs, you would have to code these boundaries into the agent's logic and hope it respects them. With Rayfin, those boundaries are baked into the API definitions. The agent can try to violate a rule, but the API will simply reject the request, and the agent will move on to the next task. The boundary is structural, not advisory. This architectural approach scales because it doesn't depend on how sophisticated your agents are. A simple script works just as well as a complex multi-agent system because the infrastructure catches the mistakes. You stop managing agent behavior through endless code reviews and start managing it through clean API design and policy enforcement. Agentic applications are the future of how companies get work done. Rayfin is the infrastructure they need to actually function. The competitive pressure. Why this matters now. In the world of enterprise technology, speed is the only metric that truly kills. It doesn't happen in a sudden crash, but in a slow loss of market share that becomes impossible to reverse. The organization that can deploy a full backend in 2 days instead of 2 months isn't just faster than you. They are operating in an entirely different strategic category. They are learning, experimenting, and shipping products at a pace that creates a compounding gap. Look at what is happening across almost every industry right now. Companies that built their entire foundation on custom APIs are still drowning in technical debt from 3 years ago. They are still having long meetings about whether to retire an old endpoint or spend 6 months refactoring it. They are running incident reviews on systems that break because nobody actually understands how the different pieces interact anymore. Meanwhile, the competitors who standardized on a BaaS model have already deployed 5 new features in the time it took the other team to plan a single API change. That speed advantage isn't linear, it compounds. If you can deploy 10 times faster than your rival, you can afford to experiment 10 times more frequently. You learn from every single failure and optimize based on what actually works in the real world. By the second year, you haven't just moved ahead. You've built an organizational muscle that the slower team simply cannot replicate. You have trained your people to work at a high-velocity rhythm, while the slower organization is still arguing about their architecture. This isn't a theoretical threat. The market is already sorting winners and losers based on this specific capability. Your most dangerous competitors are already using BaaS models because they don't want to build custom backends. They treat infrastructure as a solved problem so they can focus entirely on the product. They are deploying agents while custom API shops are still stuck in committee meetings. When a competitor launches a new AI-powered feature and you're still debating how to wire your database, the customer notices. They will choose the competitor every single time because their feature works today and yours doesn't even exist yet. This also changes the game for talent retention. Engineers want to spend their time on business logic and solving interesting problems, not fighting infrastructure fires or managing technical debt. This isn't just about making them comfortable, it's about their career development. Junior engineers learn significantly more from solving domain-specific problems than they do from learning your proprietary custom API framework. Senior engineers are far less likely to quit for a startup if they are doing meaningful work instead of acting as part-time database administrators. Your best people want to build things. If you give them infrastructure that stays out of their way, they will stay with you. Your cost structure shifts as well, but not in the way most people think. It isn't just that a BaaS platform costs less than a server farm. The real value is that you can finally allocate your human resources differently. Every engineer you have maintaining a custom API is an engineer who isn't building a new feature for your customers. Every firefighting team is a team that isn't working on optimization. When you move that effort toward feature work, you ship faster and compete better. The real cost advantage isn't a lower bill, but a much higher return on your engineering spend. What makes this so urgent right now is that you aren't just choosing between two different technologies. You are choosing whether your organization will lead the market or follow it. The companies moving toward Rayfin today are hiring the people who understand modern stacks and building products that depend on velocity. They are making moves that a custom API shop simply cannot match. By the time the slower organization finally decides to modernize, the market will have already moved on. That competitive advantage isn't something you can just buy back later. The faster organization learned more, built better products, and captured the market while you were still planning. You aren't just trying to catch up, you are playing a completely different game. The question isn't whether you should adopt a BaaS model, the only question is how fast you can make the move. The operating model shift, closing argument. Here is what nobody wants to acknowledge when they are excited about new technology. The technology is the easy part. Changing how your organization actually works is the hard part, and to be honest, it is going to hurt. Adopting Rayfin requires you to rethink how teams are organized and how work flows through your building. This isn't a metaphor, it is structural. The way your engineering teams operate today assumes that custom APIs are the default, and it assumes backend infrastructure is something teams should own and operate independently. In the old model, the path to shipping is simple. You write code, you provision infrastructure, and then you manage it forever. That entire model has to invert. Backend teams do not shift from building custom APIs to maintaining Rayfin at scale without a lot of friction. Their job description changes, their skills change, their day-to-day life changes. Instead of spending their afternoon tuning database performance or patching security vulnerabilities, they are defining backend schemas in code. They are reviewing governance definitions and collaborating with domain teams on data model choices, which is still highly technical work, but it is a different flavor of skilled labor. Some people will thrive in this change, while others will resist it, but most of your staff will end up somewhere in the middle. The skill set shift is real and it is significant. You will need less infrastructure operations and more focus on business logic and governance. This means you need fewer database administrators and more people who actually understand domain modeling. You need fewer people building APIs from scratch and more people thinking about how to enforce policy through platform abstractions. This isn't something that happens through a weekend training session. It happens through hiring, through natural attrition, and through organizational evolution that takes years rather than quarters. Cross-functional teams need new communication patterns because the work is no longer siloed. A backend definition in Rayfin isn't something the backend team creates in a vacuum and hands off to the operations group. It is something that platform, domain, security, and compliance teams have to collaborate on together. The platform team defines what they support, the domain team explains what they need, and the security and compliance teams layer on the regulations. The final definition is the intersection of all those constraints. Nobody owns the entire answer anymore. Everyone owns a piece of it. That requires communication patterns that many organizations simply haven't developed yet. The governance board becomes the critical decision point instead of the individual team leads. This is the organizational shift that feels most threatening to people, but it is also the most necessary. Team leads used to decide their own backend strategy, like whether to use Cosmos or PostgreSQL, or whether to live in Azure or AWS. Now those decisions come to the board. This is centralization. It is a constraint on autonomy. It is a loss of freedom. But here is why it is necessary. When everyone chooses independently, you optimize for individual team satisfaction, but when you optimize for organizational efficiency, you need standardization. This doesn't mean teams lose all their autonomy. It means their autonomy is constrained by the organizational strategy. Teams choose how to solve problems within the bounds of the approved architecture, and that isn't oppressive if the bounds are reasonable. The board's job is to make sure they are. This shift is uncomfortable, genuinely uncomfortable. People will resist it. Architects will defend custom approaches. Teams will fight for their own way of doing things. People worry about losing flexibility, and some of those concerns are legitimate. The board's job is to distinguish between real technical constraints and resistance that is just driven by preference. They have to say yes to exceptions that make sense and no to the ones that don't, and they have to explain the reasoning both times. The organizational change is harder than the technical change, but both are required to move forward. You cannot adopt Rayfin without changing how you operate, and you cannot maintain consistency without governance boards making the hard calls. You cannot scale without standardization. The technology simply won't work if the organization doesn't change to support it. The death is already here. Custom APIs aren't dying because they are technically inferior. They are dying because they are structurally unfit for the world that is emerging right now. We live in a world where development speed matters, where autonomy matters, and where governance matters. It is a world where artificial intelligence is starting to orchestrate decisions. Rayfin represents a different model entirely. It is code first. It is governed by default. It is Fabric native. This isn't just a marginal improvement on the custom APIs you have been building for a decade. It is a different architecture for a different era. Organizations that move toward this model will outpace those defending the old one, and they will do it now, not eventually. The speed advantage is already compounding in the market, the transition is uncomfortable, and the organizational change will create friction, but it is unavoidable. Your governance board needs to make this decision today. Not next year, not after you finish the current project. Right now, every month you delay is a month your competitors are learning how to operate faster than you. The future of enterprise backends is standardized, it is auditable, and it is ready for agents. If you want to compete in that future, you need to start building for it today. If this changed how you think about your strategy, follow me, Mirko Peters, on LinkedIn. And if you want more of this, leave a review for the M365 FM podcast because it helps more people find these insights. Connect with me directly if you want to discuss how Rayfin fits into your digital transformation roadmap. The conversation you have next could change everything.